All right, so now we're going to show some examples of utilizing the laws of exponents. Okay, so let's go through. So we have 8 squared times 8 to the 4th, right? You have the same base here, right? So we're multiplying a base times the same base, so we're going to add the exponents, and that will yield 8, same base. 2 plus 4 is 6. That is the power of the products. Okay. So then let's say we have a 7 to the 5th. Okay, and then that whole quantity is raised to the 3rd. Okay, so what you do here is you keep the base, and then you multiply. You multiply the 2 here. So 5 times 3 is 15, right? Because of this relationship, 7 to the 15ths, 7 to the 15ths, that makes that number really big. Okay, the power of the product, power to the power, right? Power of a power usually results in a huge number, usually. Okay, usually does, especially the bigger the numbers here. Okay, usually given the same combinations of numbers here. Okay. All right, so now we have, let's say, the quotient of powers. So you have a 2 divided by a 2, same base, right? And then you have the 12 and the 10. Okay, so this is the same. Carry the bases forward. Bases carry forward, 2, right? And then you subtract 12 minus 10, and that goes to 2 to the 2nd, 2 squared. Okay, that's pretty straightforward. Okay, here's a little different one now. Okay, we have a let's do a power of products. Okay, we have a 3 times a 7, and these products, 2 different bases, all raised to the same power, right? So you're going to carry these bases forward separately, 3 times 7, right? And you're going to raise each one of those to the powers, right? So that would go, let's see, 3 to the 5th, it's 243, 243, multiply that by 7 to the 5th equals 1,607, and even that may look like it's big. Times 243. It doesn't get you even into the exponent area. Okay, so it's still not as big as this one here. Sorry, yeah, this one here. Okay, which was like 7 to the 15th. Right, it gives you in scientific notation. Okay. All right, so here we go. Let's do a 45 to the negative 1st, right? This is just going to turn into 1 over 45th. It's going to be 1/45. How about 2 fifths to the negative 2? Right, this is going to turn into, flip it first, 5 halves, and then square them, right? Which is going to, 5 squared is 25, 2 squared is 4, 25 fourths, 25 fourths, which is 6 1/4, right? Or 6.25. Okay. What else do we have? How about this one? E to the natural log of 7, all raised to the 0th. All raised to the 0th. What does that equal? Okay, how about that? Equals, okay, that equals 1. How about E raised to the pi log of let's see, log of log of the square root of the sine of the square root of the sine of 30 degrees. Yeah, that's a good one. All of that raised to 0. Hey, that equals 1. Okay, doesn't matter what's in here, right? If it's raised to 0 to the 0th power, it equals 1. Okay, so let's see. All right, let's see if there's anything else that we can go over. How about this one? How about 11 to the thirds times 11 to the negative fifth? How about that? Well, this turns into 1 over 5. Whoops, 1 over 11 fifths. 11 fifths. So you can go ahead and plop 11 thirds on top of that. Okay. And that's going to end up being 11 to the 3 minus 5, right, which equals 11 to the negative second, right? And that equals 1 over 11 squared, right? And that's going to be 11 squared. I'm going to invert that, which is, that number is very small. Okay. All right, that looks like it's pretty much covered all the stuff. So I hope that this helped out, and that should cover most of 1.4.